Now, let me tell you the second numerical measure, right, which is going to help you a lot. And guys, this is the one that we are going to use in the real time. It is like an important, but this is the one that we are going to use as part of your real time jobs. It means the moment you learn about this particular technique, this is a technique that you're going to use on day-to-day basis. So let's just put a more stars on this. Okay, it is a statistical measure which we are going to make use of on every data science project. Okay, so let me tell you what is correlation. Guys, when I'm talking about covariance, right? Say as an example, I got a value of a covariance between experience and a salary. Okay, and I got a value of 10. Okay, and I'm just trying to talk about an experience of salary with respect to some of the other organizations, maybe, right? I came to be 30. Now, when you're trying to talk about covariance, did I talk about any limits? So, what is the good value? When I say positive, whether 10 is a positive or 30 is a positive or 200 is a positive. Do we have any units or do we have any limits or boundaries for us to depend upon them? Next. Did we discuss on those lines? No. So that is the disadvantage, isn't it? Right? When I'm saying the covariance between experience and a salary is 10, how should I say whether 10 is a very positive number or a very low covariance? Whether the strength of relationship is very high, very low. Definitely it's a positive. There is no doubt about that. It means I was able to understand the direction of it. But were you able to understand the strength of the relationship? Do you have any limit values saying that here? No. So that is a disadvantage, isn't it, guys? If I'm trying to calculate the covariance between two things and I got a value of 30, I got a value of 100. Whether 100 is possible over this particular metric or 200 or 300, what is the highest value that I can get? Right? You don't have a clarity when you're trying to deal with respect to covariance. So the reason, right, your statisticians came up with a much more improvised version which is called correlation. This is also a statistical numerical measure that can help you with both things. Okay. What are the both things? When you're trying to talk about covariance, it is more in the time of direction, whether it's a positive or negative direction. But we're trying to talk about correlation, it is going to tell you both the direction and also the strength. What do you mean by strength? Guys? What can you term something as strength? Magnitude. Very good, right? It means it is going to talk about how strongly those pair of variables are related to each other. You will get the direction, and also it is also trying to talk about how strong those pair of variables are related to each other. So what does it mean? If I'm able to get the strength information, do you think there should be some limits or not? Say as an example, for a mathematics exam in your high school, generally the what called the maximum marks would be for 100 marks. So if someone has secured 98, would you be able to talk about his intelligence easily or not?
Yeah.
Pretty easy, right? Because I have a number of 100 and a person has secured 98 marks. So it is easy for me to say like, okay, and the top marks is 100 and he secured 98. So it's a very gem of a candidate, right? So similarly, when we talk about covariance, I don't have such kind of a boundaries or limits for me to depend upon. So the reason I will not be able to actually talk about the actual strength of this particular relationship. But when it comes to correlation, it is going to help you with both the strength and also the direction of your relationship between two variables. So the reason we say we define correlation is a statistical technique that can show whether and how those strongly pair of variables are related to each other. Is it clear about this, guys? What is the improvisation of your correlation with respect to covariance?
Yeah.
Excellent. So the reason, the moment we talk about correlation, it means we are going to make use of your covariance formula. Just we are going to divide this particular covariance formula with the standard deviation of your x and the standard deviation of your y. So this is how the correlation formula will look like. Okay. So the moment someone is trying to talk about correlation, right, you need a covariance value divided by standard deviation of your x multiplied by standard deviation of your y. So SD stands for standard deviation. And as you know, as part of your last session, we have learned about what is standard deviations. Okay, guys, are you clear?
Yes.
Excellent. Now, when we talk about these limits, right? So general limits for correlation is -1 to +1. Okay. Now, Divya.
Yes, Tanush.
Okay. So I said the correlation coefficient values would be -1 to +1. So if I get a value of 0.1, what does it indicate? I substituted the values of this x and y into the formula and I got a value of plus 0.1. What can you comment on that?
It means they are like so close. Variants are like closely related.
See, we just discussed saying that your correlation is always going to talk about in 2 dimensions. What are those 2 dimensions? First,
negative and positive. That.
Those are 2 values within the direction. I talked about 2 dimensions.
Okay.
Your correlation tries to tell you the direction and also the strength. Agree?
Yeah.
Okay. Now, when I get a value of plus 0.1,
direction is like positive.
okay, positive, very good. What do you mean by positive? It means both are traveling together. Okay.
Together, yes.
So it means if the one variable is trying to increase, the other variable is also increasing. One variable is decreasing, the other variable is decreasing. That is called traveling in the same direction. So the reason I got a correlation to be positive. But what about the magnitude of 0.1? What do you think so? Whether it's a super strong, less strong, medium strong, or weak?
It's like the super strong because the difference is so less.
So I just told that the limits are -1 to +1.
Yes. Okay. It's plus 0.1, so it's so less.
Okay, just tell me whether it's a weak or strong.
Variation is so small, it's weak.
Obviously,
One is
right?
so weak. Yeah.
Because I said the limits are between -1 to +1. If I'm getting a value of +1, what does it mean? There is a super strong correlation between those 2 variables. If I get a plus 0.5, it means it is trending somewhere in the medium. It means it's neither too weak to be ignored or it's not a super positive to be considered. Right? And the moment you see some values around 0.1, 0.2, 0.8, it means yes, there are trending positive in the same direction, but the strength of the relationship is not that great. Yes. Able to understand this? Are you clear? Now, how do you read those values? Appreciate everyone's response, guys. So this is how your covariance does not provide such kind of a scales for you to understand the magnitude of associationship. But the moment we talk about correlation, it's actually trying to talk about, it's giving you the direction using the positive and negative signs, and it's also trying to talk about the strength of the relationship. Clear about this, guys? Are you clear? Any questions?
So, Dhanush, generally we don't use covariance at all. Correlation is the only one useful metrics for us, right? In real life world.
Yes.
Okay.
Because it has
So when it's 0, that means that there's no correlation at all. That is it a correct understanding?
Excellent, right? If you are going to get a correlation value to be 0, it means there is absolutely no relationship between the variables. But if I get a 0.1, 0.05, now we cannot say there is no relation, but there is a very small positive correlation. I would generally ignore to be of 0. Agree?
Okay.
So sometimes do not expect to be value of absolute 0. Sometimes it might tend around 0.05, 0.1. See, in all such cases, we don't call them as any positive, right? So 0.1 is like a very negligible, right? Positivity is there in the relationships. Okay.
Got it. Thanks.
Dhanush, a question here. Yeah. So with a correlation coefficient always falls between -1 and a +1?
Yes. That's what I said. That is the advantage. If you are not going to get a limits of this, then it is very much similar to the covariance, isn't it?
Yeah.
Agree?
Yeah.
Guys, agree to this point? The major advantage of correlation is you have like a bankable or limits or boundary values for us to relate. So when I say 0.95, whether you call them as a strong or weak. Manish?
It's like, I mean, it's neither weak nor strong. It's
No,
middle
it
ground.
is 0.95.
Oh, 0.9. I'm sorry. It's strong.
It's a strong, right? It is a very strong
Yeah.
side. Okay, so this is how were we able to say it's a strong, because I have a limit of +1 as the highest value. And the moment I get 0.8, 0.85, 0.9, 0.95, we say like, hey, these are so super positive number. Okay.
Yes.
How about this guy? Is anyone clear about this concept? Very, very important. Okay, so then I'm just trying to elaborate the same whatever we have discussed on the covariance side. If something is positive, it means they're traveling in the same direction. If something is negative, what does it mean? It is as one variable increases, the other variables getting decreases, right? So sometimes this negative correlation is also called as inverse correlation because it's traveling in the reverse or inverse directions. Okay, are you clear? Okay, now as a very standard question, right? If the technical panel thinks that this particular fellow does not have a good fundamental understanding, one of the most common questions that you might get is advantages of correlation with respect to covariance. Guys, what is the first advantage? You should be able to talk. What is the first advantage of correlation over the covariance?
It has strength and direction.
Okay, it has strength and direction, right? Because instead of saying direction, because direction is common in both the values, isn't it? Should I be mentioning about the direction here, or should I be only worried about the magnitude?
I mean, only the strength.
Only the strength. But how did we get those strength information in correlation?
The way it is moving towards, with the help of the direction.
With the help of direction, with the help of limits or boundary values?
With the boundaries.
Boundaries, right? So direction is always there, but it is all about the magnitude, right? It is bounded by the positives and negative ones. Right? So the reason we say your covariance is not bounded by values, but whereas your correlation is bounded by the values between -1 to +1. So the reason this is one of the greatest advantage for a person who is trying to explore the relationship between two variables. Okay. Now the other thing, let me see who can be able to help me. Yes, what is the second advantage? Let me go through the formula, right? Let me show you the formula. Maybe some people might get an idea. The covariance formula is in the top and the correlation formula is at the bottom. Now think through and tell me what is the other advantage. Yes, is there? Anyone? Okay, let me explain. So when I'm trying to talk about covariance, say as an example, I'm trying to work on a x variable is of experience. So experience is in years, right, guys? Can you calculate experience in seconds, or do we calculate the experience or deal with respect to experience in years?
Yes.
Years. Now the y variable is a salary. Now the salary, how do we refer to salaries? Yes, what is the units of your y variable, which is a salary?
Rupees.
Varanam.
Or dollars, or whichever. So based upon your country of origin, there will be certain currency. It means when I'm trying to make use of a covariance, the ultimate magnitude value that I'm going to get, whether will there be units attached to it or not? Yes or no?
No.
No. Why? It would be, right? Are they getting nullified by the denominator somewhere?
No, sir.
Right? So it means the presence of units is always there when you're trying to deal with respect to covariance, even though it's giving you a numerical value, but this particular numerical value is nothing but the amount per year is what you're trying to get as part of the result. Right? It means the units are not getting neutralized by any other value present in the denominator. But the moment you go to the correlation, do you see the same kind of issues or correlation?
No.
No. So the reason what we say, your correlation does not have units, but whereas your covariance, it has units attached with respect to those numbers. Is this all clear? Now, just spend 15 seconds of time and try to think why I was not able to think in those lines. Because I said, guys, you cannot become just a data scientist by listening to the videos or getting a spoon feeding from the mentor. Because my objective is not to spoon feed the student. My objective is always to handhold my students, right? So somewhere your independent thinking should start, right? Your logical thinking or your analytical reasoning that you are going to put in front of you is always going to help you to scale the heights. Is everyone able to understand this concept, guys? So this I ask a lot of questions even before I start something discussing about a topic, because I just want you to act like a thinking brains always, all through the things, all through the period. Okay, guys? So this is the same topic that we have learned before. Can someone point me like on the same topic we have discussed before too? So can point me?
Variance and standard deviation.
In the variance and standard deviation also, it is not a new, it's not an auto syllabus topic that I asked you here. We have discussed on the same dimension when I was trying to talk about variance versus standard deviation. Agree? Yes or no? So this is how sometimes you need to connect the dots and try to extrapolate some of the topics or the scenarios to the some of the other use cases for you to do. And right,